This is Module 2, Lesson 2. We're looking at classification of matter today. We have already learned that matter is anything that has mass and takes up space. So now we need to be able to kind of sort it out into different categories. And kind of the easiest way is to see this, at least to start with. We have matter, and matter can be one of two things. It can either be substances or it can be mixtures. And we're going to deal with substances first. Substances, as it tells you right here, can either be an element or a compound. So you have the definitions of these as we follow. Like right here's the definition of substances. You already know the meaning of physical. So if substances cannot be broken down physically, that means they can only be broken down chemically. And you should remember from the previous lesson that if you break something down chemically, you no longer have the same substance. So if you break substances down, then they're not the same things anymore. I have some examples down here of elements. Elements are the simplest form of matter that have the same properties. Oxygen, hydrogen, iron, sodium. These are all things off of the periodic table. If you break them down into smaller pieces, because they are made up of smaller pieces, then you could break them down into things like protons, neutrons, electrons, quarks, whatever. But you don't have oxygen anymore, or you wouldn't have hydrogen. So when we do some practice on this, and it asks you to identify things as an element, a compound, or a type of mixture, if you find them on the periodic table, it's an element. All right, our next one is compounds. Compounds are two or more elements that are chemically combined. So here's some examples of compounds down below. How you know they're compounds is you have two different capital letters, so it's really easy to look at them. And then this fixed ratio part really matters. If you look at water, you only have one oxygen, and this one has two. That's hydrogen peroxide. There's a big difference between those two things. This one's carbon dioxide. You have two oxygens. This one has one, so it's carbon monoxide. It's the same ingredients, but when you change that fixed ratio, you change what you have and you change the properties of the substance. And then here's two different sugars. They're the same ingredients, but in different ratios, they make a different sugar. So compounds are just like elements. They can only be broken down by chemical means, which means if you sort these out, if you take water and you break it up and you turn it into hydrogen and oxygen, you don't have those same properties anymore. I have an example of that for you here. This right here is pure sodium. It's a picture of it. It's a soft silvery metal. You could cut it with a butter knife. This right here is chlorine gas. And you can see it's like a yellowish green color to it. It smells really strong. It's very hurtful to your lungs if you breathe it. And then over here, this is what you know as table salt. It's sodium chloride. So let's look at this one. If you put sodium in water, it explodes. And clearly when you put salt in your mouth, it doesn't blow your head off. So right there's an easy property that's changed. It's also not silver in color. Chlorine is this gas. Well, this isn't a gas. Sodium chloride is a solid. It doesn't have a strong odor to it, doesn't really smell like anything. So whenever you combine things together to make a compound, their properties are not going to be like the things that made them up. Now, the other type of matter that we have is mixtures. And a basic definition of mixture is right here, and I have some food examples for you. They're easy to think about. These are physically combined. So if you really hated carrots, you could go through this salad right here and you could pick out all of the carrot pieces. And you would still have carrots and you would still have lettuce, and you wouldn't be changing the composition of anything. You would just be changing how it's organized. There's some different types of mixtures. There's heterogeneous and there's homogeneous or homogeneous, whichever way you want to say that. Hetero and homo are two prefixes that you should have learned in biology class. Hetero means different and homo means same. So a heterogeneous mixture, the parts look different, like the pizza. You could look at it and you could see the cheese and the bread and the pepperonis and the sauce. But homo means the same. So a homogeneous mixture, you look at it and you have no idea which part is where. Like vinegar is a mixture of acid and water. But if you look at it, it all just looks exactly the same. One example of a heterogeneous mixture is a suspension. Now, not all heterogeneous mixtures are suspensions, like the pizza is not a suspension. But a suspension is something that when you mix it together, like if you mix soil and water together, at first the soil would be spread all throughout your water. My water is this box. And then if you let it set for a while, most likely the soil would set down here on the bottom because it's very, very large pieces. And so it would settle out. There's two types of homogeneous mixtures. You have solutions and colloids. Solutions have the smallest particle size, so when you look at it, you don't see the pieces at all. It never settles. And a colloid is going to seem a lot like it because it has kind of medium-sized particles. So we've gone from large, medium down here with colloids, and small with solutions. But they don't settle either. They stay spread out. Some examples of colloids would be things like fog, smoke, milk, Cool Whip, glue. The pieces never settle. Like, you know, with milk, that your milk doesn't settle down. It stays all looking like a white liquid. The difference is the size of the particles and something that they do called the Tyndall effect. So I'll get to that one in just a minute. The next thing that I have is phases. Phases are just the different layers of the mixture that you have. So here's a picture example of oil and vinegar. You can see two different colored layers, so it has two phases. If we go back to the homogeneous ones, there's just one phase. Like, you can't tell the parts apart. They have one phase for both of these solutions and colloids. So there are some ways that we can separate these mixtures. You can separate mixtures with filtration or distillation. Filtering, you're just using size, and here's an example with like sand and water mixed together. You pour it through a filter, the sand stays behind, the water comes out. Or you could actually separate that based on distillation, which uses boiling points. If you put a fire right here underneath, it looks, I don't know, like a crown, but if you put a fire underneath this beaker with sand and water in it, what you would do is you could boil off the water, like right here, and catch it in a tube that would condense it, and then on the end you would get the water back out, and you could still have your sand particles over here in this part of it. It's more difficult to do this, but filtration is just using different size. You do this at home when you separate like spaghetti and water. Like when you want to pour your noodles out, you just put them in a strainer. All you're doing is separating it based on size. The water fits through the holes, but the noodles don't. You don't usually use distillation as a part of your life, but you need to know it as a way to separate mixtures. So here's kind of a cheat sheet maybe on how to differentiate between these two. You're going to have some practice problems in a minute that ask you to differentiate between substances and mixtures. And what you need to do with each example is ask yourself, is the composition of it, is it fixed? If you can change it, like with a pizza, you can put more cheese and it's still a pizza. You can take the pepperonis off, it's still a pizza. So if you can change the composition, then it's not a substance, because a substance has fixed composition and mixtures can vary. And then you can ask yourself how you could separate it. If you could pick the parts apart with your fingers, or you could pour it through a filter, or you could distill it, then you've got something that's a mixture, because those are physical separations. If there's no possible way for you to separate it except to do like some chemical magic, then you're talking about a substance. Now, I made this little chart too to kind of recap the different types of mixtures. You have solutions, colloids, and suspensions. You can see I ranked them based on size. And here I have the Tyndall effect again. I'll show you a picture of this coming up next about what they do. Solutions and colloids, we've already said they don't settle. They stay spread out in the mixture forever, the parts do. But suspensions settle, and then I'll list it again as homo or heterogeneous. Okay, so the Tyndall effect is where you shine a light through the mixture. And this beaker right here is showing you the Tyndall effect. The Tyndall effect is when you can see the beam of light. So this beaker, I know we see the light hitting the side of it right here, but if you look through it, there's no beam like there is on this side right here. If you see the beam of light, then that is demonstrating the Tyndall effect. Colloids and suspensions do that. So if you look back over here, colloids, they do the Tyndall effect. Suspensions do the Tyndall effect. Solutions do not. That would make this beaker right here be a solution. And most likely this one would be a colloid, because the particles don't look quite big enough to settle out. If you came back later and there was a layer of white stuff down here on the bottom where it had come out of solution, then it would be a suspension. You see this all the time with your headlights in the fog, how you can see the beams of the lights cutting through it because fog is colloid. The last thing before you get to your practice is just a quick review of chemical symbols and formulas. You should have had this in middle school. Symbols have to have capital letters as their first letter. If you have more than one capital letter, it must be lowercase. We already established earlier that if you see two capital letters like this one, then it's a compound. So don't ever make the second letter a capital if it's in the same symbol. Some of them make total sense, like B for boron, and then some of them, like Na for sodium, make no sense whatsoever because they're coming from either Latin or Greek words that had to do with those, and so they, for some reason, stuck with it. I'm just the bearer of the news, not the maker of the rules. Formulas have to have the symbols put together, and they have subscripts. The subscripts tell you how much you have of each element. So, for example, in this one, the subscripts always go to the right. You have 2 hydrogens and 1 oxygen. We don't write the number 1. It's just an understood number. It's actually wrong to write it. So you can interpret these, like I might have some practice questions that ask you to name the elements and how many of each. So you would look at this one and say, well, there's 2 hydrogens and 1 oxygen. So from here, you can go back to your practice time. Don't forget that you can go back and use the power of video to watch things again. You can ask me questions through the Q&A or office hours, or you can also send me a message through the inbox.